Hello everyone, myself Hans. Today we are going to solve the problem of partial differential equation. Question is given by that is find the partial differential equation of eliminating f from the z is equal to xy plus of f bracket x square plus of y square plus of z square. Given, let's solve the problem. Given, this is given by z is equal to xy plus of f of x square plus of y square plus of z square, and we have to eliminate the arbitrary constant f to form the partial differential equation. Let this is equation 1. Differentiating partially equation 1 with respect to x and y. First we have to differentiate with respect to x, taking y as the constant. So we have to write here, this is del z upon del x is equal to, here xy differentiating with respect to x, taking y as a constant. So here is y plus of f dash x square plus of y square plus of z square, and again in the bracket x square plus of y square plus of z square differentiating with respect to x. This is given by x square differentiating with respect to x, this is 2x, and y is constant so becomes 0, and z square differentiating with respect to x, this is given by 2z del z upon del x. And we can also put the here, that is del z upon del x is p. So we have to put here, this is given by del z upon del x is p, that is p is equal to y plus of f dash x square plus of y square plus of z square, and from here we have to take a common 2. This is given by x plus of z del z upon del x, and further we have to again equation 1 differentiating with respect to y, taking x as a constant. This is given by del z upon del y is equal to, here xy differentiating with respect to y, taking x as a constant, so becomes here is x, and y differentiating with respect to y, this is 1 plus of f dash x square plus of y square plus of z square, and again in the bracket x square plus of y square plus of z square differentiating with respect to y, this is given by, and taking x as a constant, so becomes 2y plus of 2z and del z upon del y, and again we have to put the value here, this is del z upon del y is given by q. So we have to put here, this is q is equal to x plus of f dash x square plus of y square plus of z square, and from here we have to take a common, that is 2 is taking common, this is y plus of z del z upon del y, and further we have to eliminate f. Once again we can also write, that is from here, this is written as y is taken into left hand side, this is written as p minus of y is equal to, here is 2 times of f dash x square plus of y square plus of z square into, here is x plus of z, and here we have to put in place of del z upon del x, this is p, and we can also write the value of del z upon del y, this is written as, we can also from here, x is taken into left hand side, this is written as q minus of x is equal to, here is 2 times of f dash x square plus of y square plus of z square, and here in the bracket this is given by y plus of z, and del z upon del y is written as q. This is zq, and we have to eliminate. We can also write the given function. This is p minus of y upon x plus of zp is taken to denominator of p minus y. This is x plus of zp is equal to, here is 2 times of f dash x square plus of y square plus of z square. Let this equation 2, and from here we can also take, this is q minus of x, and y plus of zq is taken to denominator of q minus x. This is y plus of zq is equal to, here is 2 times of f dash x square plus of y square plus of z square. Let this equation third. Comparing equation 2 and third. Here is the right hand side of the equation 2 and left hand side of the equation third is equal. So we have to know if the right hand side if the right hand side are equal, then we have to put left hand side are also equal. So we have to write the left hand side of the equation 2 is p minus of y upon x plus of zp, and the equation third of left hand side is given by q minus of x upon y plus of zq, and further we have to take a cross multiplication. This is cross multiplication with p minus y with y plus zq. This is written as, first we have to multiply here p minus of y into y plus of zq, and here is q minus of x into x plus of zp, and further we have to multiply here. This is written as py. First we have to multiply p with the y plus of zq. This is py plus of pzq, and again multiply minus y with y plus of zq. This is written as minus of y square and minus of yzq is equal to, here you can also multiply q minus x with x plus zp. First multiply q with x plus zp. This is written as qx plus of zpq, and again minus of x multiply with x plus of zp. This is written as minus of x square and minus of xzp, and we can also from here we have to take once again we have to take qx plus of zpq and minus of xzp into left hand side. This is written as py plus of, here we can also write, this is z pzq is written as zpq, and minus of y square is taken to right hand side, and this is yzq is equal to, once again we have to take qx into left hand side. This is minus of qx, and zpq into left hand side. This is minus of zpq, and minus of xzp into left hand side. This is plus of xzp is equal to, here is minus of x square, and from here minus of y square is taken to right hand side. This is plus of y square, and from here zpq, once again we have to take, here is zpq, minus of zpq and plus of zpq is cancel out, and we can take a common from here. This is once again py and minus of yzq. Once again we have to take common First we have to write here, this is py minus of yzq and minus of qx and plus of xzp is equal to, here is minus of x square plus of y square is written as y square minus of x square, and from here we have to take a common. Once again we can take a common from here, this is y is taking common, this is no, once again we have to taking py and xzp in one bracket, this is y, p is taking common, this is y, remaining is y here, and plus of xz and minus of yzq and minus of qx is taken into one bracket, this is taking minus of q is common, and here is yz plus of x is equal to y square minus of x square, and this is the required solution of the given partial differential equation. Yz minus, here is minus and minus plus 1. This is the required solution. Thank you class, and thank you for watching. If any doubt, kindly request everyone to comment the doubt in the comment section.